Okay, today we'll discuss about two operators, increment and decrement operators and bitwise operators. In earlier classes we discussed about what are the arithmetic operators, logical operators, relational operators, assignment operators and conditional operators with examples. So in today's section we will discuss about increment and decrement operator and also the bitwise operators. First one, increment and decrement operator. Increment or decrement. So here, what is the increment operator and what is the decrement operator? So here plus plus is called increment operator and minus minus is called decrement operator. So incrementing means incrementing every time a value by one number. So we can specify the increment either it was by one number or two numbers or three numbers we can specify. By default, the increment or decrement by one number only. So if you take an example, if a equal to 3, then a plus plus equal to 2. A minus minus equal to 0. So sorry, 1. If a equal to 2, a plus plus will become 3, whereas a minus minus will become 1. So this is increment and decrement. If you want to increase the more number, then what you have to go do a plus 1. A instead of a plus plus, you can use a plus 2. That is called every time it will increment 2. A plus 3, it will increment 3 and so on. The same way, a minus 2, a minus 3, we can decrease like this also. So these are increments and decrement operators. So what is the use of this one? If you want to repeat a test of instructions execution more than one time, then we need a counter. So counters are used to know how many times the process is executed. So to know how many times the set of operations are executed, we will use the operators increment and decrement to make the count. So that is the advantage of increment decrement operators. Mostly the increment and decrement operators are useful in the loops. Mostly these are used in loops. Loop means repeating the same thing. How long it will repeat, that will depend upon the condition that is given. So if you want to repeat the same transaction, that is a loop, starting and executing till again starting and executing and so on. This is called a loop. So mostly the increment or decrement operator we will use in the loops. Okay. So let us see how the increment operator and decrement operator will be. There are possibility of pre-increment and post-increment. Pre-increment and post. Let us see an example. A equal to 10. If you say a plus plus, this is called the pre-increment. If you say a plus plus, this is called the post-increment. This is called pre-increment. This is called post increment. So the same way, when you take minus minus a, this is a pre-decrement, and this is post-decrement. So what is the use of this one? In sometimes you want to increment it first and then start the loop. Sometimes you start the loop, then after completing the loop, you have to increment. So in those cases, whichever you want, you can use. So plus plus a means the value first increments, then loop starts. Here a plus plus means value loop started, then value will be incremented. So this is use of the pre-increment and post-increment. In the same way, pre-decrement and post-decrement. So these are the concept about the increment and decrement operators in C. So increment and decrement operators are basically used in loops. Plus plus is called increment operator, minus minus is called the decrement operator. So we can do pre-increment, post-increment, pre-decrement, and post-decrement. Let us see an example through program that you can understand more about this concept. See here, Control N. Now start writing the program first. Documentation session, program on increment and decrement. Decrement operators. Right. Now start to include the file. Include io, sorry, stdio.h. Main. So first what I have to do, I have to declare a variable int a. So at beginning, I don't know the value, that is why that's why I'm a equal to some 2. That means the value in a is 2. Let's see. I'm printing printf value in C before pre-increment. So when you try to pre-increment, before the pre-increment, what is the value in A? That is that I'm telling that percentage D comma A, because percentage D here means now specify integer value. So plus plus C. So I'm in a pre-increment. So now I am trying to display this value again here. So value in A, not C. Value in A after pre-increment. So the same way I will do A plus plus. So now I am again displaying this value here as after. So I do one thing here. So value after post increment. Right. So I am displaying 3 values here. All are the A values. So first I am displaying directly the value of A, that is 2. Then I'm doing pre-increment and then display the value. Again, post-increment, I'm displaying the value. So first what I have to do, I have to compile, I have to save. So the file name is increment decrement.c. So go to execute and compile. Is there errors or not? No errors. Then go to the output, run. See here. Value in A before pre-increment is 2. Value in after pre-increment is 3. Value in after post-increment is 4. Hope you understand clearly. So means that first the value is increasing. In pre-increment, the first value is increasing. The first value is increasing. The post-increment, the value will be increased later. See, if you want to know more, you will do one thing. I will remove these two things. This one. I will remove these two statements. You can understand clearly. Now here I am doing only the pre-increment. See, compile. No errors. Run the program. So what is here? Value before pre-increment is 2. Value in A after pre-increment is 3. So generally we have got the 2 value, and after because of the pre-increment it will become as a 3. So now what I will do is I will remove this one. I will hide this one. This one also. I am hiding these two statements now. Now see what I am doing here. A value will be 2 displayed first. Then post increment, the value will be displayed. So when you say here before post increment, the value will be 2 itself. So 2 and 3. So this is a way you can use the pre-increment and post-increments also. When you want to do pre-increment, you can pre-increment it. But mostly you can understand this concept when you are using the loops. That will be clear. Next, the same way, you can also see the decrement concept also. So when you mention like this, here minus minus, here minus minus, remove this one also. So I will, for the clear output, I will do one thing. I will use slash in here. You can get clear output now. Execute, compile, no address, execute, run. So see here. The value before increment is 2, pre-increment, decrement, pre-decrement is 1, and post-decrement it is 0. So I have to use the decrement, not increment here. Okay. So this is the concept. We can both use increments and decrements. So let's see the next concept, that is the next concept is the bitwise operators. I'm removing here. The concept is bitwise operators. bitwise operator. There are different operators like AND, OR, XOR, XOR, NOT, shift right, shift right, shift right, and shift left. The first operator here is bitwise AND. This is called bitwise AND operator. Bitwise OR operator. Bitwise XOR operator. XOR. XOR operator. This is not operator. Bitwise not operator. This one is shift right, shift. I will explain one by one clearly, you can understand. So here AND, here we are using as a bitwise operator. We already told that the AND operator we have used it in the same as a special operators, where to identify the address of a variable. So here the AND operator we are using for the bitwise AND operations. Pipe symbol we are using for the bitwise OR operator. Pipe symbol is available above the enter key. And shift, whenever you press the shift 6, you will get the exponential symbol that will display the bitwise XOR operator. Tilde character, when you press the shift and next to the escape key, that is the tilde character. When you shift the tilde character, that is called the not operator. When you use double greater than, that is the shift right, and double less than, it is the shift left. So what is the bitwise operators here? Concept means when you want to add binary numbers, when you want to do some operations on binary numbers, we'll use the concept of bitwise operators. So bitwise operators are useful to do the transactions on binary digits. Binary digits are nothing but zeros and ones. Zeros and ones. So I will explain you one program that will detail you about the concept. Let's see, here I am using a value A. The value in A equal to 5. Let us see value in A equal to 5. The equivalent value, the equivalent binary value for the given value 5 is 0, 0, 0, 0, 1, 0, 0, 1. 0, 1, 0, 1. So how do you get this output? Simple. We are already the table of the binary digits. According to the binary digits table, you can easily get everything. See here, I will show you for you. So here 0, 0, 0, 0, that describes a 0. 0, 0, 0, 1, that is 1. 0, 0, 1, 0, that is 2. 0, 0, 0, 1, 0, 0, that is 3. 0, 1, 0, 1, that is 4. 0, 1, 1, 0, that is 5. Small mistakes. 0, 0, 1, 1, that is 3. 0, 1, 0, 0, that is 4. 0, 1, 0, 1, that is 5. Now we have get the value as 0, 1, 0, 1, it is 5. So 0, 1, 1, 0, that is 6. 0, 1, 1, 1, that is 7. 1, 0, 0, 0, that is 8. I will do till 15 because the next, whenever you do the transaction, that will be come as an output. That's right. Okay. 1001, that is 9. 1010, that is 10. 1011, that is 11. 101100, 1100, that is 12. 1110, 1101, that is 13. 1110, that is 14. 1111, that is 15. Sorry, 14. 1111, that is 15. So this you remember. Now I am to the calculations here. The first I have taken the value a equal to phi. The equivalent value is 0, 1, 0, 1, 0, 1. Okay. Next, I'm taking the b value as 9. B value as 9. What is the equivalent value for the b value here? 0, 0, 0, 0. Next 9 value is 1, 0, 0, 1. 1, 0, 0, 1. So, okay. Now, let's start the first operation, bitwise AND. So here, the concept is A and B. A and B. So here the A value is 0, 0, 0, 0, 0, 1, 0, 1. B value is 0, 0, 0, 0, 1, 0, 0, 1. So now we have to add these both values. So when you add these both values, means the concept here is if both the digits, digit in the first line and digit in the second line, both are similar, then you will get 1. Both are 1, you will get 1. See here example, when you see 5, the extreme right digit is 1. In 9 is of the extreme right digit 1. So here 0, 0 will be 0, 0, 0, 0. Here 0, 1. So 0, 1 again it will become 0. 1, 0 again will become as a 0. 0, 0 will be 0. Here both are 1, 1. That's why it will become as 1. Now the output is, see here 0, 0, 0, 0, 0, 0, 0, 1 is, that is nothing but 1. So this is number 1. This is number 1. So when you go to the next one, A pipe B means A or B. A value here is 0, 0, 0, 0, 0, 1, 0, 1. Next one 0, 0, 0, 0, 1, 0, 0, 1. Now see, the concept here is if any one of the digit, if any one of the digit is 1, then it will become as 1. Any one of the digit is 1, then it will become as 1. See here, here both are 0, no possibility is there. Not possible, not possible, not here see 0, 1, yes possible, then it will become as 1. 1, 0 again becomes 1. Again 0, 0, not possible, is 1, 1 is just 1. So this is the output. So what is 1, 1, 0, 1 here? 1, 1, 0, 1 is nothing but 13. 1, 1, 0, 1 nothing but 13. So let's take another example, that is A, B. So here 1, 2, 3, 4, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 0, 1. Now see, what is the concept here? What is A cap B tells that if any one of the digit in both any one of the operand is 1, then it will be a 1. If the both operands are same, it will not possible. So here see, both are 0, 0, then become 0, then 0, 0, then will become 0, 0, 0. Here one operand is 0 and one operand is 1. So then becomes 1. Here 1 is 0, 1 is 1. Yes, it is possible. Next 0, 0, not possible. 1, 1 also not possible. So here see, the concept here is one digit only 1, another digit should be 0. But whenever you take the example, extreme right both are 1, so those also will become as 0. Now See 1100, that is nothing but the 12. Equivalent digit is 12. Now next one, tilde A. So what the concept here is, the reverse, mean the complement like this. So see here, the A value is, what is the A value here? 0, 0, 0, 0, 0, 1, 0, 1. So here, this value will become as 1, 1, 1, 1, 1, 0, 1, 0. So what is there here is 0 will become as 1, 1 will become as a 0. This is the complement. So this is about AND, OR, XOR, and NOT. I hope understand. Now shift right and shift left. Shift right and shift left. Take, let us suppose, take the B value here. So what is the B equivalent number here? 0, 0, 0, 0, 1, 0, 0, 1. So here shift 1. Shift 1 means one digit has to shift right. So now here the 0 will replace the position of the 1. And again 0 will replace the position of 0 and will become as 1 will replace the position of 0 and so on. Now the output will look like what, like this here, 0, 0, 0, 0. 0, 0, 0, 0, 0, 1, 0, 0. So how it will come possibility is, we have to move, see here, what we have to do is here, see, this digit will replace here, this will replace here, this will replace here, sorry, this will replace here. So it means that what we have to do is this one will replace here, this will replace here, this one will replace to this here, again 0 will replace to 1, like this. So it means one digit right side shifting. So when you see, take the same concept, b greater than b less than 1, it means shifting to left. So here the extreme left is 0. So the position, if you change, see here, b value is 0, 0, 0, 0, 1, 0, 0, 1. Okay. Now see, the concept here is shifting into this side now. Like this. Now see, what will be the output here? 0, 0, 0, 1, 0, 0, 1. So this will be the output. Hope I understand clearly. So B double greater than 1, B double less. This is what? B double less than 1. Sir, is possible to shift to 2 times. Yes, B double greater than 2 means shift right 2 bits. B less than 2 means shift left 2 bits. So you can take like this also. So then you have to take, every time you have to shift to two bits left. Okay. See here the same example I will try to apply to A also. A, the value is 0, 0, 0, 0, 0, 1, 0, 1. So now A, so you mean the left side. So 0, 0, 0, 0, 1, 0, 1, 0. So when you go to the A, this one, then you have to right side. So 0, 1, 0, 0, 0, 0, 0. 0, you have to write move towards move side. 0, 1, 0, 0, 0, 0, 0. This is all. Because here, see what happened here is 0 occupied the position of 1 and 1 occupied the position of 0, and almost all the rest of are zeros, no problem. So same thing will happen. So this is about the concept of bitwise and or XOR not, shift right and shift left. So bitwise operators are mostly used in the case of binary transactions. If you want to do the binary calculations, then you use the bitwise operators. So same concept I will try to write in the program, then you can understand easily. So Control N, then a window. So
Can't see your screen. The program screen I can see.
hello, program and bitwise operators. As include stdio.h.
Sir,
Yeah,
sir, I can't see Dev C++, sir. I can only see the whiteboard.
yes, I do one thing. I think I forgot to share the screen. Is it okay now?
Okay, sir.
So and or not complement bitwise right and bitwise left. Here there is no required of B. Here this is one R. R. This is one and. This is one XOR. So see the output. So I will do one thing. I'll give the next line here. Understand clearly. See here. Is it correct or not? We already hear the outputs also. So as per the earlier, we have already right here now. The first one will become as the output A and B as 1. Next one 13. Next one 12. And third one, that is not of 5. Not of 5. That is minus 6. Something is wrong here. I will check again. Shift right. Whenever you shift the right, the value will become as a 2. When shift right, its value become as a 10. So because when you shift the value to left, it will become as 1 0 1 0. So A left means 1 0 1 0. When you see the calendar, 1 0 1 0 is nothing but a 10. We already discussed earlier. 1 0 1 0. I do one thing. I keep the screen like this only. So see here the values here, whatever the values we are getting here. So the first value is 1, and the next value is 13, next value is 12, and the not value is somewhat I get different. I will check once again. Right shift, it is 2, and left shift, it is 10. Okay, we can check it again once again, no problem. Where is the problem with the AND operator? We'll see. A equal to 5. When the reverse it, when the complement of A, what will be the B? Let us see once again the whiteboard. Here the complement of A, that will become as 1 1 1 1 1 like this, but we'll get different answer here. I'll check once again. Something wrong, I will check once again. I will come from the next section. Okay. So this is all about the increment and decrement operators and also the bitwise operators. Okay. I'm already posting the same classes videos in the YouTube also. You can go to the link of my link on my name or YouTube. Otherwise, I will share the links to you. I think I have completed around 7 classes till today. All the 7 classes I have posting regularly in the group. Just to go through the YouTube, then you can find the class also. If you have any doubts, you can refresh yourself in the class also. Okay.
Yes, sir.